All right, in this unit I want to talk about the Swift syntax for creating your own custom classes. So first I'm going to start playground here real quick, and I'll call this Unit 3 Classes. And I'll put it on my desktop so I can find it. And now we get something to play with. And I'm going to go into the notes, into the classes and structures section here, so I have something to reference. But I'm hoping you're all going to help me with this, because I've read it once and my brain hurts. I was working on this yesterday. Saturday was grading day, but yesterday was iOS day. And I've figured out I can't do this all one day. My brain hurt by the time I got through this chapter, and I'm not sure I got through all of it. There was a lot of stuff here. And unfortunately for us who are learning this language, there's a lot of stuff there we might never need. It's one of those things that's included in the language. I hope you can remember it when you need it, but go from there. And I also discovered today that at least on the machine in my office, and I'll have to check to see which beta it's running, there is what's the latest beta out there? 7, maybe 8. Let's do a quick check.
On Saturday.
Okay, I'll take your word for it then. They're about due. Download 7. All right, now I don't know exactly what I have installed in my office. I should check. But one of the features of the class language, I got an error message saying this hasn't been implemented yet. Whoa. All right, and it was basically class variables class variables, or what they call type variables. And that hadn't been implemented yet, and I had that in your assignment. Speaking of which, now that I've closed the browser, let's head back to the web page real quick. I have added what I have for notes right now, which I wouldn't call complete yet, but then my Unit 2 notes aren't complete. There's nothing in there on dictionaries, which is why Adam will have to apologize. Well, it is quarter after. If you need an ice cream bar, since you're already late, there's an ice cream truck parked out front, and they're giving them away for free.
That sounds fantastic, actually.
Breakfast. Go get one. I'm sure they didn't have any ice cream in Las Vegas, right?
I wasn't in Vegas.
Vegas?
No, I'm in Vegas in 2 weeks.
Oh, great. Anyways, apologize because you gave me a dictionary. I didn't even recognize it because I don't have any dictionary notes. But anyways,
I just read it. I was like,
what?
It looks like a dictionary. I saw it.
Leave it. Ignore it. That was brain dead time. Swift classes, my notes as they are up there. They're not complete, but what's up there is up there, and it'll be updated as we go. I've also posted the beginning of the assignment. What do you mean? Oh. Posted the beginning of the assignment, and I have modified this for Swift. You can usually tell when it says make a playground. But I modified this for Swift, so if you want to get started on it, you can. But it may change as we go. I'm already playing around with it. The data structures, there's so many different possibilities. And this example is another one where there's different possibilities that I'm going to kind of leave it up to you and how you lay things out. So I have to modify the assignment a little bit to give you some flexibility. All right, I've already changed the words arrays to collections. So if you want to use dictionaries or classes or structs or whatever, it's up to you. I'm not going to force you down any road once you figure out how you want to solve this problem. Within limits, I do want you to use at least a class with some stuff inside it. So, for today, what kind of class do we want to build? And don't say a rectangle class or a cube class or any of that kind of stuff that's in the book. You can look those up. What do you want to build?
A general purpose class, something that.
A what? You mean a class, an object class, right? So, no, that's a little too generic. Do student class, okay? So how do we define a class? Well, in Swift, we've got a choice, right? We can define a class, or we can define a structure. Which is better here?
From what I've read, classes are better.
Classes are better because?
They pass by reference.
Okay.
Structures copy.
Okay, that's an important point. Let me pause this so I can close the door. Actually, Justin, will you get the door for me? Just kind of block it closed. Classes pass by reference, which means that if you say class 1 equals class 2, it doesn't create a copy of the object. It just creates a copy of the reference to the object, so you can now have 2 pointers to that same object. A struct, on the other hand, is a value type. And so when you say struct 1 equals struct 2, it makes an exact duplicate of that structure. Now, from Reen's perspective, classes are better because we don't get duplicates. But really, when you say A equals B, what do you normally want to do? Copy B into A and make an exact duplicate. So structs take up more memory, but they do duplicate, which maybe is better. But then how often do I want to copy one student's record into another student's record if we're doing students? That's not a big factor. However, when you pass them as to a function, if you pass an entire structure to a function, it'll pass by value. It'll make a copy versus passing a class passes a reference. So that's a subtle difference. Go ahead, Paul.
What is the purpose of having 2 separate classes pointing to the exact same instance?
2 classes pointing to the same instance. It's like saying, why would I have a pointer to the middle of an array? All right, I might be walking through a whole bunch of things, and so I've got one that's pointing through it, and then there's a pointer that's pointing to the same one, and I can make the pointer move down the array. I think that's the best way to visualize it, is occasionally you need 2 pointing to the same thing just because one is the max, and then you're working on the min, and the current is equal to this one. They're both pointing to the same thing. Doesn't happen a lot, you're right. But occasionally, particularly if you're walking through an array of these things, it can happen.
I think one of the main spots it's used is, like you said, if you're going to pass it to a function, a method, like passing it by reference, the function then changes
The master.
the master without having to create a copy of it.
So for the recording, let me repeat what he said. If I pass a class, an object, not a class, but the object instantiation of that class, if I pass that instantiation to a function, it doesn't copy it, it sends a pointer to it. And what's important to recognize is if the function then changes the contents of that object, the master copy's being changed. So the master copy's got a pointer, the function's got a pointer into the same object. And then when the function closes, that one goes away. All right, so there it happens. We don't tell it to happen, but it happens by default when you pass an object to a function. Neil, you give me that look.
Oh no, I have a thought like, what if there's a condition inside the function that gets changed by the function that could then cause I'm trying to think how to word this, but like, if the function is checking for some sort of property and that property gets changed, it gets bumped up, and somehow the way the function's set up then reads the new value and it like goes through some sort of infinite loop down to hell.
It could, but the only way the infinite loop would happen is if the function called itself.
Okay.
But it doesn't go to hell because usually when you have a function that calls itself, that's called recursion. Right? When a function calls itself, that's a pretty advanced programming technique. When a function calls itself, there has to be an out. Stop calling myself when this happens. There's always an out, otherwise it's an endless loop. So same thing, you could have dozens, if you had a recursive function that sends in a class, you could have dozens of pointers to the same thing. Could happen, I suppose. We can what if it to death, but. All right, so structs send by value. What else, what other differences? You remember?
Classes have more functionality, which is kind of,
Classes have more functionality, how so?
or I'm saying, right?
The one thing that classes can do that structs cannot is they cannot inherit. Structs cannot inherit, classes can. Now, we haven't done any examples of inheritance. If you haven't read that far, I encourage you to read that far because you're probably going to run into it in the real world where you have one class that inherits the properties of another class. very common example of that is a combo box, which has a text box embedded inside that. It inherits all of the properties of a text box, and then it adds to it. And that's a little different. Inheritance is a little different than creating one class and using it as a component of another class. That's different. There's some good examples in the book with vehicles and so on that kind of give you a handle on it. But I think once again, when you get to the real world, how complicated your classes get depends on the application in those classes. There's probably a library of classes, right? Adam helped me out here, and at Century, Irene helped me out. There's a library of classes that you can reference. Thousands. You know, it probably correlates to one for every table in the database plus, right? More and more. So that's something to take a look at. So that to me was the big kicker. That and for you to remember that when you're using structs, they pass by value versus reference. But the big kicker is inheritance. For us then, does it make any difference? Maybe, maybe not. There's one other thing that a class can, no, I take this back. I was going to say we can have a custom initializer, a constructor. In Swift, it's called an initializer. We can have a custom one, but I believe that was for both. That we can create a custom one for both, but they behave slightly differently.
According to this list, they are.
What?
According to this list, it's in both.
They can both do it. Right. So for our purposes, I don't see a big difference.
I did find a block that stated that for structures, they should only be used for simple data information. And there are cases where the compiler will determine that the data is not going to be changed, and it will pass by reference anyway because it's faster.
Good, and we don't have to worry about it. All right. And you said that structs should only be used for simple structures or simple objects. Define simple. For you and me, that might be 2, 3 properties. But for a real programmer, it might be less than 200 properties. I don't know what simple means. I mean, the examples they give in the book have 2 or 3 properties. They're really good examples, by the way, particularly if you want to write a game in iOS, because one of the big factors of games is where is my center, where are my boundaries, where's my XY, where's my size. Those are very, very common as you're moving objects around the screen, and where are they on the screen and moving them. Those structs that they demonstrate are pretty common. Okay, so we want to build a student. Let's build a class, just because that's what we're used to. But if it's a class, then you start with the keyword class, and then the name of the class, student. Class names, like type names, typically title case, or as the Swift book calls them, large camelback. There's large camelback and there's small camelback. That's Apple again. You wonder why in the systems class or in the RDD class we have so many terms for the same thing. Well, here's why. Everybody dreams up something new that means basically the same thing. So we'll call this class student, then curly brackets. Now we're done. If we're creating a structure, then it would look like struct instructor. Not much difference. Okay, so the next thing we want to know is how do we create members? Reen, it was your bright idea. So what's the first member that you want?
First name.
First name. And now we have to decide whether it's a var or a let. Right? And that's another subtle difference between these two now that I remember it. But typically these are going to change so they're vars. If you make them a let, you're kind of creating that type constant that's built into the class that everybody uses. I remember we created static constants in our classes in Programming Logic Intermediate. We created these static constants, meaning that every instance of the class shares this variable. They don't all have their own personal copy of it. If you call this a let, that still doesn't make it a class constant or a static variable.
I thought it was interesting that you could declare it as a constant, but not define it, and then you.
And then still change it. Mm-hmm.
Well, you could initialize it, and then after that was.
You can initialize it
And then
once. I think you get to set it. So when you define these as a let, as a constant, a class constant, you define it as a let, you get to initialize it once. Even in code later, after you've instantiated, you get to set it once, and once you've set it, then it's locked in place and you can't change it. Personally, if it was a constant, I would change it here, but again, it's some interesting, as Adam said, some interesting flexibility there to say later I want to define the initial value of this. Maybe I ask the user, what's the largest random number that you want to generate?
Or a key,
Or what?
or using that as a key.
As a
You
key?
set the key and then you can't change it again.
Okay, or what's the key for this object, right? And again, yeah, we could have a student ID, right? So let's do that real quick here. Let's have a student ID that is going to be, I'm going to make it a string. Now with a let there, I can set it once. After that, all I can do is reference it. For the name, maybe I want to change it. And I'm guessing you're going to want a last name as well. Now for the instructor, what am I going to have here? Pretty much the same stuff, right? Which gets into the conversation we were having in RDD the other day. Do we create a person class, and then after the person class, the student class can inherit all of the stuff of a person, and so can the instructor? Okay. And then the person has, and maybe we'll take a look at that next time. Redefining this to define a person, and then define what's different between an instructor and a student. But for right now, just so you can see that structs and classes work very similar, we can do the same kinds of things. What are you complaining about?
Initializer.
Oh, I think I need parentheses. Yes, no?
You do that within the class.
Let's go look at Volker's notes here real quick. No, it doesn't like those. This is why you have to write code. You can read that book till your brain goes sideways, and mine did yesterday. But if you don't try some of this stuff, it's harder for it to stick into your brain once your problem here.
Yeah. I had to create
I think you
an
need to
initializer.
give them a value. Is what it's complaining.
Yeah.
Each one of my variables needs an initializer, even though I defined its type. Huh.
Or you need a method initializer.
Okay. If that's going to shut it up, then I'll do this.
Now, you can change student ID even though we initialized it to.
Yeah, I think,
I'm surprised.
let's find out.
But okay. The struct does not need an initialization.
Struct doesn't need them?
Correct. Well, at least apparently that doesn't give the error.
Okay. Or I have to define an init. And we'll talk about the init. That's, for some reason, I don't know why, the Swift book waits 100 pages before it gets to initializing. Because I guess it's initializing them this way. So there's another difference between these. One I can initialize and others I can't. So now let's go down here and see what happens. If I instantiate this, I'm going to create a student pointer.
With the init, you don't need to initialize the values in the bar levels.
Say that louder.
With the init method in the class. you
Right.
don't need-
Then I don't need these up here. I understand that.
Okay.
All right, but the init method, I'm going to push it off a little bit yet, and we'll put that in here in just a little bit. So there I've initialized a student, but notice the difference here. All right, not the greatest idea, but you get the point. Equals an instructor. Why don't you like that? Oh, because
Do
it's
you have to define it? Yeah.
No parentheses.
I think you need to initialize the variables.
You have to give it values.
So, notice how I initialize these. A structure can be initialized immediately, but I would have sworn I've created one of these that wasn't initialized. But because these aren't initialized here, I have to define them as initialized. That's my guess. So we're testing things out here. If I just give them a boring initial value, okay, then can I do this? Yes, now I can do that. So somewhere you have to initialize them. You either initialize them as you create them, as you define them in the class, or you must initialize them when you declare them.
Can you do that? You can't do that with the class.
No, you cannot do this with a class. Right? If I do the parenthesis here, now it says which way do you want to initialize it? You can do it this way, or you can do it that way. Okay? So I'm going to do it this way. So now it wants a student ID, so I'll give it 1, 2, 3, 4, 5, 6, 7, 8. And then it wants a first name. And now I've got an instructor with that information. Notice it did let me override the instructor ID.
Do you have to set it up so it looks like a dictionary?
Where? This?
And yeah, instead of having instructor ID there, can you just,
No, you don't have to set it up that way. I can use dot notation and change things. So let's try this. So now I can say instructor dot instructor ID equals, whoops, ID equals, won't let me do that because of the let. Right? It's constant. Cannot assign instructor ID in instructor. Right? So that won't work. But all the others I can. I can say that instructor dot first name equals Volker, and instructor dot last name equals Gall. That I can do using dot notation. And then if I make these big enough over here, I should be able to see the other values that are in there.
I went, in your is that the initializer? Where you have bar instructor equals instructor, and then it says, in the parentheses, instructor ID, does
Yep.
that have to be there?
Or can you just have the values?
Or can you just have the values?
No, you must have the names, okay? His question is, can I leave these out, right, and just put in the values? I don't believe so. Okay. When you're initializing classes like this and when you're initializing structs like this, you must give what the book refers to as the external name of this. And in this case, with structs and classes, the external names and the internal names, what the class uses for them, are identical. And they're required.
I like it better that way anyways, because you know what it is.
It takes more typing though. But it does help to be able to see those when other people are looking at them. And when the help comes up, it points to the different objects, or it lets you know the sequence that these are in there, and just press tab to move through them and just fill in the blanks. So it's very nice. So you don't really even have to type them. Downside is if you decide to change the name like I did here, you got to change it down here because it does not get caught up. Where before, if I just had the value in there, it doesn't matter what I call it, right? But now that I have these labels on my parameters, if I change the member names up here, the property names, by the way, there are no members, they're just properties here. Where's my properties? Right there. Where's my setters and getters for the properties? Right there. If you only knew what we had to go through in Objective-C to create classes, first of all, there's two files. There's a .h file and there's a .m file. The .h file is the interface file. It just shows you here's all the different members in the class, and here's a template for all the methods in the class. All that was in the H file. And then there's the M file that has all the code for the methods, and they were in two different places, and it's left over from C. Okay. Gone. I'm curious, I'm ready to jump into the GUI version of this and see what happens when we start building a GUI interface to an application and use Swift behind it. Because a lot of the files are going to be gone that I'm used to seeing, M's and H's, and trying to keep them all sorted out and head exploding. This should be better. Everything in one place. Okay, so there's some examples, but let's try, the next thing I want to try is after the student here, I want to say that the student.student ID equals, and that won't let me do it because it's defined as a let, so I can't change it. So I would need to define that in a different way so that I can get at it. So for right now, let's just make it a var. The other thing I wanted to mention is notice I defined my student pointer with a let, but I defined my structure with a var. I can define the structure with a var, but if I do, these values are then locked in place. I can define my instructor with a let, but when I do, these now become invalid because this is a constant instructor record that cannot be changed, including its insides. Even though the insides are defined with vars, you can't change the insides if the container itself is locked. So often a structure is defined as a var, particularly if you want to be able to change the contents of what's inside that structure. Why doesn't that happen here though? It's letting me change the student ID. Because what I'm really defining here is a pointer. A pointer to a chunk of memory. So for the recording's purposes, I'm holding my hand in the air. This is my chunk of memory. Here's the pointer to it. I can change the insides of this, but the address, the pointer of this object in memory is never going to change, so you make it a let. The pointer doesn't change, but you can still change the stuff that's on the inside as long as it's defined as a var, which typically it would be. That's what members and properties are all about. Again, no properties. We don't have to define setters and getters. We had to do that in C#. And it was even more complex here. Everything had to have a setter and a getter. Adam and I are already having this conversation, but it seems kind of weird to not have those, but we do. Right, we have the ability to watch. What do they call them? Observers? Is that what it was? A type observer? We have the ability to watch any one of these properties and say, if it changes, run this code. Before it changes, if you're thinking about changing it, run this code. And what we'll have to investigate sometime in the future is if I don't want anything changed, then how do I abort? That I haven't figured out yet. But we can observe. What did we ever do in a getter? We got the value from the member, passed it back, right? Return the member value, send it back. That's what we're doing here. We never did anything else. For a setter, what did we ever do? We said, take this value, put it into the member. Yeah, that's what happens here. But if you include an observer, then you can intercept that and take a look at it first.
For validation.
For validation. If you need to. If you don't need to, then just stuff things in there, because I just used a setter, right? I just set the student ID. And to get it, you do exactly the same thing. You put it inside a print line statement or put it on the left-hand side of an assignment statement. So the setters and getters, I think the geniuses at Swift decided that, those are pretty common. And if we need to, we'll put these observers in, and that'll help us. So it's simplified immensely. Here we go. That's it. You can have as many of those as you want, as in any class. Questions so far? Comments? Define them. These are stored properties, and they store values. Later on, we're going to get different kinds. Defining them, we use let for classes, and we use probably var for structures. To get at the properties, you just use them and change them. There's an advanced topic called lazy properties. We'll leave that off. I put a note in here to say they exist, but if you read them and you're going, huh? I'm not surprised. Pretty advanced. It's for properties, or for particularly when you're incorporating objects into other objects that are complex and you're not sure you're going to need them. Then make them lazy and they'll assign them what it needs to and save some memory that way. You can tell the people that wrote this language have looked at some pretty complex code. And they're trying to incorporate things, or maybe written some pretty complex code, and they're trying to incorporate things into the language to make advanced code a little easier to write. Constructors, that's a lie. It says they're not defined. It's not true. A little later, I think I renamed them. Maybe I hope I didn't forget to save that piece. I did. Oh my goodness. I've got more than this in my notes now. There are constructors. So since it's there, let's talk about them. What are they called? They're called initializers. That's their term when you're referring to them. You use initializers, but the function that you use to make that happen is called init. So we define an init function, and then we can set values to things. So that would then allow me to remove these equal signs and call them, let's just make them strings. And then I get my error. But if I then come down here and define, did I need to put a function on that init function? No, it's just init. Now it's complaining because I haven't initialized everything, probably. Are you happy now? Yes. And everything else down below still seems to be happy as well. So this is the constructor. It still exists, but you don't need it necessarily if you initialize the members to start with. And sometimes that works and sometimes that doesn't. So in this case, what have I done? Really nothing, just transferred the responsibility for initializing to a different place. But what if I want to initialize and set values at the same time? So this is a generic init. When you say student parentheses, you get this initialization. You can create your own custom initializers that set custom values. Okay, so here's my init from Fahrenheit, the local value, and what type is it. Okay, so this is what you put in the call. Okay, so I haven't tried this, so let's be brave. Local and external names. The external name is what you put in the call, kind of like we saw when we did this down here. This is the external name. And there's internal names. What are they called inside the functions? Now this one's got an external name and an internal name. That's a little bizarre to me sometimes. What it allows you to do, what this from Fahrenheit allows you to do, is externally create a sentence. So right here, boiling point of water is Celsius from Fahrenheit. Save it as a Celsius temperature from this 212 Fahrenheit. So we're kind of creating a sentence is the reason they have these external variables. It's kind of left over from Objective-C. In Objective-C, we sent messages to functions, and that was a really bizarre concept. But a lot of people liked it because the messages read very well, kind of like this does, Celsius from Fahrenheit. But you can also define an internal name for it. Notice that that's the internal name that's used here in the calculation.
Why don't they just use the same name?
You can. All right. If you're doing a function and you want to use the same name, I think you put a # on it. Say my internal name and the external name is the same. In methods like this and initializers like this, I believe you don't have to do anything special. Let's move ahead to the next page. You don't have to do anything special, and now they're given the same names. So this doesn't designate an external name and an internal name. It just designates internal names, and then you designate the same names down here. So it's very similar to what we did with the structures.
For that, if you go back to the book, we cover the, like, you can declare multiple of the same type variables in one line.
Right.
Is that?
This is not declaring them. Oh, you mean here?
Yeah.
Did we miss that? I just don't do it. That's why I didn't talk about it. It's not my favorite thing to do, but obviously you can. Creating values, and notice this is a let. Okay, so it's suggesting that once we set these, they're not changing. Seems a little odd to me that I define a color object. Oh, it's a struct. That I define a color object with 3 colors, and they're all fixed once I set them. But on the other hand, here's some examples, right? Here's magenta. When does magenta ever change? Well, I could define that. The way they're doing this here is they're defining named colors, magenta. But if I wanted to change the color, or if I wanted to define the color of Justin's shirt, I could define it as blue to start with, and then later on define its color as red, and still define red, green, and blue to it. As the game changes, the object color might change. And if the object color changes, you'd have to make this a var. This one's saying, I'm going to define a constant color by sending in red, green, and blue values. And then I'm going to call that magenta. And once I give it an initial value, that's it. Magenta is always 1 part red, 1 part, or no parts green, 1 part blue.
Or 1 part fully red, part fully blue.
Pardon me?
1 part now is fully red, fully blue.
I think that's what that means. These are percentages. So this is 100% red, blue, and green. And what they do with it, we can't see right now, right? Because they haven't defined that function yet.
How come the top initializer uses the keyword self.color?
Because the names are the same. All right, it's a good question. Why the self and why not here? All right. Because here we're setting the property red equal to red. Wait a minute. The parameter name is red. And the property name is red. And to distinguish the two, because saying red equals red, what are we doing? We're talking about this one. So to distinguish the two, this self.red means my property called red versus the parameter called red. This is another very common technique. You have a initializer that says this is the value for red, this is the value for green, this is the value for blue. And it gives them the same names as the property names. If they have the same name as the property name, then you have to distinguish one from the other. Take my parameter, stick it into the property, parameter, property, parameter, property. Down here I don't have that trouble because I'm sending in how much white am I putting in, and it sets each one of the colors to a percentage. Which is an interesting way to deal with that. I don't know if you ever noticed it, but whenever you look at shades of gray in HTML colors, you haven't been there yet, but any of these color RGB color systems, the shades of gray, I noticed it one day, all have the same values. How much value you put in there, more lightens it, less darkens it, I think. 0 is black. Okay? And then as you get to 100%, it turns into white, but everything in between is a shade between white and black. Even though you're mixing 50 parts red, 50 parts white, or 50% red, 50% green, 50% blue, by the time you mix all those, it turns into a shade of gray. So that's kind of the logic here. I would call it, I don't know if you can call it init gray, I don't think you can. So let's create another init for student here, where we send in all the values. Okay. And instead of using what the book used, where I use exactly the same as my parameter names, I could do that, right? I don't know if you want me to do it that way, Paul, or do you understand what we did before? You understand it, okay. So instead of doing it that way, I'm going to say, I gotta check the syntax here again real quick. I don't think they need, yeah, they do need types, okay. I'm going to say that the ID is a string and the, what the, and the first name is a string and the last name is a string. Since I've given them different names,
Close the parentheses before.
Oh. Yeah.
since I've given them different names now, I don't need to use self in my variables here when I start typing. So now I can simply say that the student ID is equal to the ID and so on. Just having a few issues here, aren't
First name is last name?
I? Yep, I know. Like I said, I'm having issues. Stop it. So now down here, I could create another student. All right, and here's the ID. If you press, come down to select it from the list, now all I have to do is tab. Tab. Tap, tap, moves it over. All right, so now I have a new student, and we can see that information over here by peeking in the playground that all that stuff transferred over. Many of the programs I've written in the past do both. They provide these, and they provide, a blank constructor in case you want to start with an empty one. And they also provide a constructor that provides every single value in the list. And you can go on from here and create a different one. Say, I want to create a new student with, I want to be able to create a student with just an ID number. And when that happens, then the student ID is equal to that ID. But I still have to initialize all the other stuff, otherwise I get errors when I use it.
Lowercase I.
That was interesting. I noticed that you could create two new methods with the same type of variable, but a different name, and you can call them separately.
Yes, so that's also another interesting way of dealing with it is you could have this one uses string, string, string. And in most languages, if you have another initializer that accepts 3 strings, you now have a duplicate function because it has the same name and the same types. But in Swift and in Objective-C, because we're naming the parameters and we're requiring that the external name be there, we can flip them around. So let's try that. Now, why would I do this? No particular reason, unless I want to provide my user the opportunity to send in first name, last name ID, really has no big advantage from a programming perspective. Right? But the point is that I can have 3 different strings coming in a different order, and this you can't do in most languages, and I don't even have to change the code.
The example I saw up there was they had from Fahrenheit and from Kelvin.
Right.
They were both doubles. And
They
so
were both doubles, and normally in most languages, that's not allowed, right? And some of you don't have the experience that he has, but this is init with a double, this is init with a double. In most languages, that's a duplicate function because the languages can't determine the difference between one function with a double and another function with a double as a parameter. Can't do it. But because they're named, and they're required to be named, we can do that. So it gives us some flexibility, though, is there a lot of value to it? I'm not sure.
Could you, with that sort of flexibility, pretty much then create a person, create a person class and use your init to identify if it's a student or instructor based on the value, like what the person puts in?
Yeah, because you could have one constructed as instructor ID and one that has student ID. That'd be a little bit of work though.
You'd have to, the thing I think you're going to start realizing in this class is that there are a number of different data structures. It was a whole course for me once upon a time. Data structures that you can create. When you talk about that person class, when I add that, what's the difference between them? Well, they each have an ID. One of them is an instructor, but how do we then blend these things together? We'll see that. Maybe next hour we'll fight with that, but there's a few other things I want to talk about first. I didn't sense that, Adam. That's good. So what we did here with 2 inits that have 3 strings as parameters in all other languages, as far as I know, maybe not Objective-C, but in all other languages, that's not legal. Because that's called the signature of the method. The signature of the method is the method's name and the parameter types. And these are identical. 3 strings, 3 strings. So the same signature and the same name can't have 2 methods with the same signature. In Swift, maybe Objective-C, I'd have to go back and look, but in Swift, we can get away with this because each of our parameters has that external name.
So that name's actually part of the signature then.
It is, must be. All right. And when it popped up in the list, it gave me 2 of them with 3 strings, and I could pick which one I want. You want the one with the first name first or the one with the ID first? Pick either one. But also notice real quick, why would I make the names the same? Maybe the question that Paul's asking, why would I make my parameter names here instead of first, last, ID? Those are a bit misleading. Well, not misleading, but not as helpful. First, last, ID is not as helpful as first name, last name, student ID. First name and last name make better sense there. Otherwise, is he first in the class? Is he last in the class? Are those boolean? No, those are strings. What do those mean? In this case, it's not bad. But in some cases, there just isn't a good name for it, like X and Y in a lot of the examples they have in the text. X and Y are what we call these things. Height and width are what we call these things. Why have the parameters be W and H instead of height and width? Can make these pop-ups as readable as possible and not have any conflicts. All right, let's take 10 and come back and do some more.